Hi everyone and welcome. So this is Mr. Reen and I will be walking you through lessons throughout this year. It's going to be mostly self-paced, so if you need to stop at any time and rewind or go back and look at something, you can certainly do that. Let's get started. We're going to start Unit 1 today, and this is called Number Operations and Number Sense. And what we're going to be looking at here today specifically is integers and absolute value. And this can be found on page 46 of our textbook. So since this is the beginning of our unit, let's go ahead and write our names up at the top so that we don't lose our papers. And let's go ahead and put our class hour, and since I don't have one, I'm just going to mark 1A, 1B. And then go ahead and write today's date. And obviously that's going to change, so I'm just going to put today. So go ahead and actually put today's date, whatever that may be. All right, so what are we going to actually be learning today? We're going to start looking at integers and absolute values specifically. So the first thing we're actually going to be doing is we're going to compare and order integers. Compare and order integers. You may be saying, well, what is an integer? Well, we're going to talk about that in just a minute, okay? Compare and order integers. The next thing we're going to do is we're going to find the absolute value of an expression. Find the absolute value of an expression. Okay, so again, we're going to compare and order integers, and we're going to find the absolute value of an expression. Okay, if you need some more time to write that down, go ahead and pause. Otherwise, we're going to continue on. Oops. Sorry, my thing's a little jumpy here. It'll go. There we go. Sorry. Got a tiny little space that I can do my finger on, so I gotta get pretty specific with it. All right, let's take a look here. So example 1 says, write an integer for each situation, then identify its opposite and describe what it means. Letter A says 23 degrees Fahrenheit below 0. So again, first we need to know, well, what exactly is an integer? So an integer is any positive or negative whole number. At least that's how I say it. Okay? The book's going to give you this really weird definition. This is my way of saying it because it's a whole lot easier to remember. Any positive or negative whole number. So what exactly is a whole number, first of all? So a whole number is a number that does not contain a decimal or have a fraction in it. Okay? And then obviously you already know what positive and negative means because you've worked with those before on the number line stuff. All right, so let's take a look. So we have 23 degrees Fahrenheit below 0. So should we represent this with a positive number or a negative number? We want below 0, so we need a negative number. So we're just going to write negative 23. Next it says to identify its opposite. So the opposite of negative 23 would be positive 23. Now describe what that means. So if negative 23 represents 23 degrees Fahrenheit below 0, then what does 23 mean in this case? So that means that it's 23 degrees Fahrenheit above 0. Okay, so think about those antonyms that you learned in English class. All right, the opposite of a negative is a positive, so the opposite of below would be above in this case. Okay, so pretty simple overall. Okay, let's try 1B down here. It says 11 inches more than normal. So first we need to write the integer itself. We need to show more than normal, so we think positive or negative. In this case, it would be a positive one, so we're going to do 11. Then we need to show what the opposite is, which is going to be negative 11. And then explain what negative 11 would actually represent. In this case, it would be 11 inches less than normal. Okay, and that's it. So again, tell me what the integer is, tell me its opposite, and then describe in words what the opposite means. And just use the same wording that they have. Sometimes you may have to change it just a little bit, but try to just use what they have. It makes it a lot easier. No need to reinvent the wheel here. Okay, let's go ahead and take a look at the next part. Whoops. Again, it's really jumpy. Sorry about that. Okay, so let's take a look at the guided question. So go ahead and pause it, try these on your own, and come back to me as soon as you're ready. All right, let's take a look. So we have 1A, which is a loss of 8 yards. Okay, so again, that would be a negative 8 since we're losing. Its opposite would be positive 8. And then the situation would be a gain of 8 yards. A gain of 8 yards. Okay, so that's a good football question right there. All right, 1B, a deposit of $15. So this one kind of trips some people up. They don't remember what a deposit is. A deposit is when you get money into your account. Okay, you're earning money, you're putting it into your banking account. All right, so if you didn't know that, go ahead and pause it and try this one on your own real quick. Otherwise, we'll continue on. So let's go ahead and take a look. So a deposit then, since we're gaining money, that's going to be positive 15. Its opposite is going to be negative 15. And then this is the word that a lot of people tend to forget. So the opposite of a deposit is called a withdraw. All right, so we have a withdraw of $15. All right. And that's it. All right, so let's go ahead and move on to part 2. Boy, this thing is really jumpy today. There we go. Okay, so we're going to use the integers graphed on the number line below. Part A says to write 2 inequalities involving 1 and negative 2. Well, what exactly is an inequality? Let's make a little note over here in case we forgot. So an inequality can be the less than sign or the greater than sign or the equal sign. All right, less than is the one that points left, and if you kind of hold up the number 2 in your hand and then turn your hand to where your palm is facing you, so the bottom of your fingers is facing you, and you turn it just a little bit, it makes the less than symbol. All right, so I always remember the left hand contains the less than. All right, and then if you do it on your right hand, it doesn't, so obviously that's the greater than one. Okay, and we all know which one equals is. Okay, so we need to write 2 inequalities involving these 2 numbers. We have 1 and negative 2. So we need to ask ourselves, is 1 less than, greater than, or equal to negative 2? And obviously it would be greater than. So we're going to write 1 is greater than negative 2. Okay? Now, you're probably thinking, well, hold on, Mr. Reen. It says to write 2 inequalities. We just wrote one, so what are we supposed to do? Well, what's the other symbol we can use? We can also use the less than one. How can we use the less than? We're just going to switch it around. So we're going to write negative 2 is less than 1. Okay? And that's it, literally. So write the first one in the order that they have it, then switch it around using the opposite inequality symbol. All right, let's take a look at 1b then. It says replace the circle with less than, greater than, or equals in negative 4 and negative 6 to make a true sentence. So for this one, let's go in the order that they already started. So we have negative 4. And we need to figure out, is it less than, greater than, or equal? So this one is actually greater than negative 6. All right. Now remember, when you're on the number line, the greater the number means it's farther towards the right. So if you graph this out, if you look up here on the number line, here's your negative 6, here's your negative 4. Which one's farther on the right side? The negative 4 is. So it's actually larger. Okay? Negatives are the opposite of positives. The larger the number gets, the smaller it becomes. Okay? Whereas in positives, the larger the number gets, the larger it is. Okay? So negatives are the opposite of that. All right, so let's switch it around then. So then we're going to say that negative 6 is less than negative 4. All right? Go ahead and finish up and go ahead and pause whenever you're ready, and let's try the guided questions and come back to me when you're ready. All right, let's take a look here. So again, we're going to write two inequalities involving negative 7 and negative 3. So we're going to have negative 7, it's actually less than negative 3, and then we're going to switch it so it's negative 3 is greater than, I'm sorry, I wrote the wrong one. I said it, but I didn't write it right. Greater than negative 7. All right, and then the last one is replace the circle with the symbols for negative 1 and 2. All right, so in this case, we would have negative 1 is less than 2, and then we switch around, so 2 is greater than negative 1. All right, go ahead and finish up, and let's turn the page. All right, example 3. Bethany and her friends played a question and answer video game. Their scores at the end of the game were 1, negative 5, 0, negative 1, 2, and 4. Order the scores from least to greatest. And then the first thing they want us to do is to graph these on the number line. So let's do that first because that does help us. So we have 1. Make my ink just a hair bigger. Let's see here. Gotta figure out how to do that right there. Okay. So then we have negative 5. No, it didn't work. All right. And then we have 0. And then we have negative 1. We have 2. And we have 4. All right, so for this one, they want us to graph it, or sort it, order it from least to greatest. All right, so which one is the smallest number? Well, that would be the one farthest over on the left. So in this case, it would be negative 5. So we would have negative 5, comma, and the next one would be negative 1, comma, 0, comma, 1, comma, 2, comma, 4. All right, and that's it. All right, go ahead and pause it whenever you're ready, and we'll try the guided question and come back to me as soon as you're ready. All right, let's take a look. It says the recorded highs in degrees Celsius at Niagara Falls from February 21st to 28 of a recent year are 4, 2, 3, negative 6, negative 5, negative 1, 0, and 1. Order the temperatures from greatest to least. Okay, greatest to least. So this time we're going to be going large to small. So you can use the number line if you want. You can actually use the same one we did up there, just maybe use a different color or put the dots below or above so that way you can keep those apart. But I think we can do this without. So let's look at the list here. So what's the largest number we have? It looks like we have a 4. All right, I'm going to cross mine out. Then as I look through, it looks like I have a 3, a 2, and then I have a 1 and a 0, and then I have a negative 1, and this is the part everyone forgets. Which one's actually next? Is it negative 6 or is it negative 5? It's actually negative 5, right? So, because it would be farther over to the right. So it'd be negative 5 and then negative 6. Again, remember, the farther it is from 0 on the left, the smaller it is. So the farther it is towards the right, the larger it is. Okay? All right, now we're going to switch gears, and we're going to take a look at absolute value. So let's just read what it says there. It says absolute value is the distance the number is from 0 on the number line. So this is kind of weird, and my board's jumping all over the place. There we go. But really what you're doing is you're literally counting like how many jumps or how many spaces or leaps, whatever you want to call it, from the number to 0. All right, so let's take a look at number 4 here. Okay, letter A says those bars mean the absolute value. So how far away from 0 is it? So how far away from 0 is negative 4? Well, let's use the number line here to illustrate what we're doing here so you can kind of get the mental picture of it. And then once you understand that, then I think you'll be good to go. So if I put my dot here at negative 4 and I need to go to 0, all right, well, how many jumps is it? Well, when I go from -4 to 0, I'm going to jump 1, 2, 3, 4. So the answer is 4. And I already had that one worked out for you, which is okay. It just kind of helps you out there. But that's what it is. It just wants to know how many jumps it's going to take. Now, it doesn't matter if you're going towards the left or towards the right. And the answer is no, it doesn't. You can go from 0 to the number, or you can go from the number to 0. It doesn't matter which way you go. And that's because whenever you're traveling, it doesn't matter whether you're going north, south, east, or west. You always count in the positives, right? Think about on the ruler. Have you ever seen a ruler that has negatives on it? No, because we don't measure distance in negatives. We measure it always in positives. So it doesn't matter which way you're going, it's always going to be a positive answer. So even though we started on the negatives, you're still going it's going to become positive because you're counting how many spaces. You don't count -1, -2, -3, -4 on your fingers. You count 1, 2, 3, 4, 5 on your fingers. All right, so we're using our counting numbers, or our natural numbers as we call them. All right, let's take a look at letter B. So we have the absolute value of -8 minus the absolute value of 5. So again, here's our number line, kind of just visualize it in your head. All right, so if I'm at -8 and I need to jump to 0, how many jumps is it going to take me to get to the number 0? In this case, it would take 8, right? So that's 8. Then we have minus in the middle. And then we're on 5. How many jumps will it take to go from 5 to 0? So look at the number line we have. Again, it doesn't matter if we're going east, or in this case, we're going west. It doesn't matter because we're still counting 1, 2, 3, 4, 5. We're counting positive numbers. Okay, we don't count with negatives. We only count with positives. All right, and then from here, you're going to solve it. So you have 8 minus 5, which is just 3. And that's it. All right, go ahead and pause it and try the guided questions on your own and come back to me as soon as you're ready. All right, let's take a look. So we have 4a, which is the absolute value of -3. So again, if I use my number line from up above, if I start at -3 and I jump towards 0, I'm going to end up with 3 jumps. So the answer is 3. Okay, let's look at 4b. If I have the absolute value of -4 minus the absolute value of 3, it's going to take me 4 jumps minus, and that's going to take me 3 jumps, which together then would be 1 jump. All right, and that's it. Next, we're going to evaluate. And evaluating just means to plug some numbers in, okay? So let's take a look here at the first one. So it says, evaluate 6 plus the absolute value of x if x equals -2. Well, they told us what to plug in. So they want us to do 6 plus the absolute value of -2. All right, so we know 6 is obviously 6. There's nothing wrong with it. It's good to go. But we need to figure out what the absolute value of -2 is. So again, think to yourself, how many jumps is it from -2 to 0? In this case, it would be 2. So what this actually is asking you for is just 6 plus 2. All right, and then of course we know the answer is 8. All right, go ahead and pause it and try at least 5A. 5B might give you a little bit of troubles here, but at least try 5A here, and then come back to me as soon as you're ready. All right, let's take a look here. So we have evaluate the absolute value of y plus 8 if y equals -7. So let's write it first. All right, so when I have the absolute value of -7 plus 8, what I need to do is figure out how many jumps it is from -7 to 0. So it would take me 7 jumps to get back to 0, and then we're going to add 8 to that, which is going to give us 15. All right, the next one, let me read it to you first, and if you had a little bit of trouble after I read it to you, I think you'll understand now what you're supposed to do. So let's take a look. So it says evaluate 9 minus 5 times the absolute value of z if z equals 3. I'll read that again. Evaluate 9 minus 5 times the absolute value of z if z equals 3. All right, so let's plug that in. So if you have a little difficulty, go ahead and pause it and try solving it now that you know that it means times. Okay, so what we have is 9 minus 5 times the absolute value of 3. Well, you have to remember your PEMDAS, which is order of operations. And PEMDAS tells us we multiply and divide first, and then we add and subtract. So we actually need to do 5 times the absolute value of 3. We know that the 3 is 3 jumps away from 0, so this is actually 9 minus 15. All right. Now you're probably like, well, you can't do 9 minus 15. Well, you can. We're going to learn a little bit different way to do it. But for now, let's just kind of mentally picture this for a minute. So if I have a number line, let's go. Let's see, I do 9. So it'll be 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. All right, let's just draw a really quick little number line here. So if I'm at 9, right here, and I need to jump back 15 spaces, right? Because subtraction means to go towards the left of the number line. So we need to jump back 15 spaces. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, where did we end up at? This was -1. This was -2, -3, -4, -5, and this makes -6. All right, so I ended up at -6. All right, and that's it. Thanks so much for watching, and I look forward to working with you this year. If you ever need anything, if you're in class with me, raise your hand. Otherwise, if you're out there in YouTube world, leave a comment and subscribe. Thanks. Bye.